Hello everyone, welcome back to my channel. In this video I'm going to be trying to go over some quick tips and tricks I have for Lemax's Isle of Doom made in 2004. This is an animated building that's very popular but prone to many issues. I've fixed up 6 different ones or so, and I have 3 of them here. This is my original one that I've done videos on in the past, showing some of the motor revivals and things. And it's now suffered from the same thing as this building. This Isle of Doom is prone to a couple different failures. Number one is the full string burnout, which happened on this, which is basically Lemax wired in series LEDs from this point under the pier to some LEDs in here, then to a couple in here, then to the skull eyes and the one in the basin, and they're all in series. So if one of the bulbs dies or goes bad, it could either just kill the string completely, or it might shorten the lifespan of the others because it's shorting out. I really hate how Lemax did that, because on all of their newer pieces they'll usually have, color coordinated voltage regulations. So you'd have like your lime green bulbs just off of one type of resistor, and then ultraviolet off of a different type, and so on. But with this one, it was not regulated whatsoever. So if your power supply had fluctuations or anything really, or they got rusty, because in here, these are the ones that normally die, is this did not have any silicone, and since they're exposed to water, boom. What's surprising is this piece was actually a brand new Isle of Doom that was opened up by a client who then sent it to me to repair. And yeah, it was brand new and already had the failure with this string burnout. And honestly, it's not worth the time to try and get them partially working. I spent an hour last night trying to do that, and I tried just testing individually with the wires going to the different portions, where I disconnected them out of series and tried to just use a low voltage adapter and a resistor to try and see if I could get any life. The only one that showed any life was underneath the pier. The rest of them seemed to be dead, and it's just not worth the time. So I've done a couple of these Isle of Dooms with the lightning, so I just used the exact same code, soldered up my LEDs, and boom. These are pixel type bulbs, so you only have to make one connection, and then the rest of them will just work. You just code them for whatever color or pattern, and you don't have to go individually stringing them with resistors and everything, because that's just way more time consuming. Technically, if you wanted to have an original Isle of Doom with all the original bulbs and stuff, you could go strategically rewire point to point, where you have positive, negative, resistors, everything, but properly regulated off of 5 volts. You could do that, but it would take way more time. And I basically, like, having the upgraded lights that I've done here is easier and faster to do. So, and cheaper. Or not necessarily cheaper material cost wise, but in my opinion, just worth it because of how much easier it is and how much quicker it is. And you really won't be wasting a bunch of time fiddling with the little bulbs, trying to solder them on the tiny wires and everything. So that's failure number one. The other failure is where your sound and animation die. This can happen on pretty much any of the Lemax buildings, really, where if you don't have any sound, and if this guy isn't moving, if he's not coming in and out as normal, also you can tell because the cannon light should light up every once in a while. If none of those things are working, your main board is dead. Or you might get really, really lucky and the wire just got desoldered, but I highly doubt that. Because this one back here just had that happen where the board died. So that is definitely a problem if those are all dead. I'm working currently, and I'm planning on posting another video on actually making a revive board. As I've done this on the Frankenstein's laboratory, where I actually made a brand new chip with Arduino to replace the original board. My client for the for Frankenstein's laboratory did not want the sound, because most of us, including me, I rarely have my pieces on with the sound, so I don't really blame him. So I actually made a new loop for Frankenstein's laboratory that was longer, where it actually took a minute instead of just 30 seconds. And so with this Isle of Doom, I'm planning on actually making a revival board. And I've already actually recorded the source audio off of a working Isle of Doom, the one that was mine, which I'm planning on selling. But I've recorded the source audio so that you could actually put it onto a new MP3 chip and have the exact source file audio versus it being like a recording through a microphone. It's the actual source audio. So I'm planning on making a revival chip, but that would probably be the most painful part, is trying to fix this board. Let's go into the boards quickly. The one here in the front is the Mr. board. The one here in the back is regulator board, and this one's your animation board. The Mr. board looks like this if it's ripped out. It has a Phillips screw that's located underneath the pier. And this board is... I haven't really seen this board fail. Knock on wood, but honestly, the Mr. is really messy and it's just, I don't know, kind of annoying to deal with. And also, this board is the sole reason why Isle of Doom uses the 24-volt AC adapter. And quick points of reference, even though these are red and black wires, these are AC. So don't think that you can attach wires here and be safe, because these are the 24-volt AC, and they'll kill most of your stuff if you try and attach it there. Then this middle rail, we'll look at this board here for reference. So you have the AC contacts. This middle rail here is positive, and the one going around here is negative. And you can see here they have these big beefy diodes that are forming a rectifier to take in the 24-volt AC and rectify it into about 34 volts DC. Because AC is a waveform, and the 24 volts is basically a medium of that wave. And so if you rectify it so that it's not switching polarities, then it'll be still about 24 volts if you load it, but then they'll usually put a capacitor on there to basically keep the AC voltage at its peak. So the peak of the waveform is actually about 34 volts, which I measured with my voltmeter. And so that's 34 volts DC. Then it goes back to this board, which I hate. I really hate it. Here it is. This is what that one looks like, which I've ripped out. This one still has the original one in it. Mainly because this board serves two purposes. If your string of lights is still working, these ones that go up through here that burned out on this piece, they're powered from this board in their own separate special way. Basically, if I can get it to sort of sit still here. Here's my screwdriver so I can point here. So if we look, Lemax follows this same pattern for most of their buildings on their boards. Is the outer rail that's forming this U shape is negative. They'll do that on their animation boards too. So if you see a trace that's going around, that's probably negative. Then this triangular part that's right here is your 30 volts. coming in. So that's this white wire in my case on this building. I think they kind of use the same color wires on all of them, but basically whatever wire's coming from here to that point is your 30 volts positive. Then you've got the ground, which will be connected here as well from your negative supply. And then they have resistors on the back side, these little tiny ones, that are supplying voltage to these points. So you've got this point, you've got this point. And basically those are usually what fail. It can vary though, but these are really problematic. But these points that it's powering are what power the string of lights that are in series going around here that burned out. So that's where they're connected to, is these points. Then right here, attached to the heatsink, is your little IC chip, which is trying to regulate to 5 volts. I did test these chips, and if you can, remove them immediately. Don't even bother trying to run your Isle of Doom normally with its standard chip. You can buy a bunch of these from Amazon. And I'll go ahead and open it up here quick so you can just see it on camera a bit closer. These I've used many times now to fix these Isle of Dooms. Because even if Isle of Doom isn't in here for this repair, seriously do this, because this chip will save your piece long term. What this does is it is a newer version of this same principle of using an IC chip to regulate downward, but it doesn't have any of the hang-ups that this one does. If you've ever felt Isle of Doom on the back side of the tower with your hand after it's been running after any amount of time, this will be hot, literally burning hot. Like you can, when I was working on this piece last night and it was still using the regular IC chip, I put my finger here and it actually feels kind of like touching a hot glue gun. It's actually hot. It actually needs that heatsink. I think it actually needs a bigger heatsink with water cooling. Basically, this chip dies, it can overheat, crack, and if it kills, if it dies, it'll most likely kill your animation board with it. So this board, your animation board that has the sound and controls the guy coming in and out and the cannon, if your IC chip here fails, most likely it kills that with it. Because all of a sudden this one will stop regulating voltage correctly and it might just spike all of a sudden up to like the 34 volts DC. And that just is boom, that board's just dead. So remove this board as quickly as possible. The way it works is this point here is your 4.5 to 5 volt ish range. So this right here, you'll usually have a red wire coming off of, so it's literally this point. You'll usually see a red wire and maybe a couple other wires. I've seen it vary a lot from piece to piece. Sometimes they'll use all of these points. Sometimes they only use 2 of them, like it used on this one. Basically, whatever points that are connected here, you want to move to your new board, because they're supposed to be regulated to 5 volts. You'll usually have one thicker red wire that goes to here, to this board. That's the most important. The way that I've installed these, so if you're lucky and your lights are still working for these buildings, you can leave the white wire going down to that board and a black wire going down to that board to just supply the resistors there. But just remove anything that's on that one point. You can technically leave whatever others that are connected to ground on this side. So you don't technically need to remove any of the wires that are going around here if they're all working fine. You just want to remove the wires that are coming off of this point. Then on this board, it depends on the one that you get, because they can vary from Amazon. You might get ones that are smaller, or like these chips that I bought as well. They're a little bit different. All of them will have an input and an output. And on most of them, ground is common. And you want to make sure that you have your ground be common in this case. So here, for this board, it actually has a built-in rectifier, so it could directly work off of 24 volts AC. So it actually has AC input. Then these points are the voltage positive and negative, which are again the input. Then these points here are your output. What I usually will do is I'll actually attach my positive voltage. So in this case, it's the wire coming here from the middle directly to the V plus, and then one of the wires coming from the negative side directly to the negative plate, because it's basically shared throughout this whole thing. And then what's really nice about connecting it in that way is if you connect ground here, you can cheat and not have to connect ground here. So instead of having, because technically if you attached your lines to the AC, just simple easy screw terminals, then you would also have to connect your negative going to this. So you would have to find the negative side of all the circuits and attach it here. But if ground is common, so if you have just a negative wire going to the main negative up here, ground is shared throughout this whole piece. So you don't have to go and detach them off of this board. So you can just leave everything else. And then, so if you attach positive, negative, then you just simply have your positive output right here. And before you attach this, before you solder it onto there and plug it in, make sure you regulate it. So you'll need a voltmeter. This is the one that I use all the time. I really love this voltmeter. So you want to just turn on your voltmeter and attach it, to the points and see what is it saying. So once you have it wired up and it's getting power, you'll have a little power LED here that lets you know it has voltage, and then you just want to have your prongs attached and see what is your readout. Obviously this one's not attached to anything right now. But then you'll need to use a small flathead screwdriver and tune this. I always forget which way to tune it, but you just want to rotate it one way or another and you should see some change. So just start rotating it. If you see the voltage going up, move it the other way, whatever, as necessary. Usually I tune these to about 4.80 volts or so. Lemax obviously uses their 4.5 volt adapters, but if you actually go and plug in one of their 4.5 volt adapters, they'll usually be slightly higher than actually 4.5 volts. In my case, since I also am using an Arduinos like to have 5 volts, and pixel LEDs are infamously power hungry, so they like to have a bit more juice. So having it at 4.80 isn't going to harm the Lemax board, especially since it's been running off of this archaic piece of junk here. So really, you don't have to worry about it with the voltage being a little bit higher than 4.5. Just make sure it's not over 5 volts. I wouldn't ever tune it to be like 5.2 or whatever. Technically, that probably still wouldn't kill anything, but I just like to be on the safe side and have it a little lower than 5 volts. And these things are really nice though, because no matter what the voltage is, they'll regulate themselves to be, pretty much outputting what they need to. They'll usually have a minimum of like a volt or so drop. So if you attach a 5-volt adapter, these probably won't be able to output 5 volts if you had it set at 5 volts. So if you had like a 6-volt adapter though and plugged it in, or 9-volt, the animation and motors, all of that would work just fine. And you wouldn't actually need the 24-volt adapter anymore if you're a little scared of it like I am. Because this darn thing actually heats up whenever it's plugged in because it's a coil transformer. Versus if you have a newer type self-regulating adapter, it's way safer. But either way, this is a self-regulating adapter, and it will keep your stuff way safer. This thing is going to change the way Isle of Doom functions, basically, because now this is cool to the touch because it's not doing anything, so it's just sitting in there sort of dormant. And then I have my new board just shoved into the corner underneath, so you can see the little red power LED, and it's just sort of shoved up there so it's not using up any valuable space. And then I have my Arduino that I coded, an Arduino Nano, just stuck there. And I put masking tape over stuff so that it doesn't short anything or bridge to any contacts. And if you're wondering about these loose wires, they're what's left of the original lights that were coming down from the different points. So anyway, I think that pretty much sums up this video as far as my quick tips and tricks. Must buy is this. If you have the confidence to try and do some voltage, just some minor soldering-ish. I don't know. It still does take, obviously, a decent enough soldering iron to desolder those and put them on here. But definitely recommend putting this on there, because this is really going to ensure that your piece stays safe. It won't overheat, because like this board doesn't use the heat sink the majority of the time. It's cool to the touch right now. The only time that this one heats up is if you have the mister running. This darn thing though will literally heat up anytime the piece is plugged in. So it's really unsafe. I don't like it. The board kills stuff. I just really recommend replacing that thing. And I'm also going to give you a couple quick bonus tips if you're inclined to try and do some troubleshooting yourself, and if you're also curious about doing some Arduino coding like I was. If you're wondering about reviving the original board, I figured out which leads here do what. So again, you can see this one's kind of in a state of disrepair. This one, the mister was dead as well. It was not the board though, because I actually tried replacing the board with a working one that I retired from a different piece, but the board was fine. It's actually the mister that died. And so we're going to be replacing it with a new wick. Mister that's way less messy and actually does a better job at misting. And as far as this board though, the animation board, it died, and I figured out what leads sort of go to what. Let me get my screwdriver to point. The leads on the ends here, so this one, which is the fourth over, is the cannon light. So if you attach, I believe it was ground or 5 volts, either one though, that'll trigger the cannon. And then this one is door close, I think, and that's door open, or vice versa. But either way, those two pins right next to each other control the guy coming in and out of the door. So those 3 pins are the ones that I'm going to be needing most for reviving this chip, because I don't actually have to go and reinvent the wheel and actually make a new motor controller. It's like in the case of the Frankenstein's laboratory piece that I revived, the whole board was shot because somehow a capacitor exploded and it was literally dead. The whole board was basically toast. The only thing that worked on it still were the resistors sort of regulating power for the LEDs on it. But the whole board, as far as the transistors, everything was just dead. So on that one, I actually had to use a LL92H motor controller to actually get the motor to work again, so that it was being controlled by a new chip, and I literally tapped in the motor sensors to the Arduino, and everything's controlled by the Arduino now. So with this one though, all I'll have to do is attach some data pins to those 3 leads. I don't really care about that green blinking light, I don't think, but I might try and figure that one out. I wouldn't be surprised if it's this next one over to the cannon. Wait, no, that would be that one. Right? No, I'm looking at it's so small, but no, I think it would be that one. I wouldn't be surprised if the green blinking LED is that one. Which I still don't really understand to this day what the green blinking bulb is. Because it's this one. It's actually controlled off of the animation board, but I have no idea why. I don't really understand what the reasoning is. It's sort of in tune to the soundtrack of, like, when he opens the door, it sort of blinks, but I have no clue why they found it necessary to do that bulb. It's just really kind of weird. But yeah, I wouldn't be surprised if that next pin over is the green bulb. But then all I have to do is attach data pins to those, attach my main Arduino ground to here on the outer rail like I mentioned, and then I'll probably just attach positive to somewhere else, although trying to see, I don't see an easy positive on this one. If I were to guess, I would say it's this right over here. There's like a trail going down. I'd say that's probably a main positive. But definitely use your voltmeter, and I'm going to be doing a different video on this piece once I get it revived, and more of my in-depth analysis on that. But figured since I'm filming this video and I've got the 3 here, I can share that info right now if anyone's curious about it. But yeah, so thank you for watching, and if you have any questions or comments, let me know. Best of luck, honestly, on fixing Isle of Doom. I don't let my I guess cynicism towards the piece deter you, because I'm just kind of sick of working on it, because of it's just such an obvious flaw with the way that they wired this string of lights. If it was just the voltage regulator, I wouldn't be that opposed, because honestly the technology was just they were working with what they had back then, and the technology now is just way better. So I could get behind just, you know, having to replace this board. But honestly, the amount of pieces that I've seen that have this string of lights dead is kind of appalling, and it's all just because of laziness. Instead of having separately little dun resistors to power the bulbs like they normally would do, they just were lazy and used the string of lights to just quickly get it done. So but yeah, best of luck on fixing your piece, and let me know if you have any questions. I'm happy to take send-ins, but it's really a labor of love, and it's not going to be like a quick you can flip it now if I fix it for you. I'm I'm not trying to necessarily make money on this, but I don't want to just be working for free almost, because like Isle of Doom is really a painstaking piece to fix. So it takes hours of work, honestly, to fix. And so yeah, I'm happy to help you for free over text and stuff if you want to do the work yourself, but sending it in, we can always talk quotes depending on what's wrong and things. And other Lemax pieces are usually easier to fix and way cheaper. So, but Isle of Doom is really, it's kind of like a statement piece, but at the same time I'm sick of working on it because it's just always the same thing. So anyway, thank you for watching, and I hope this was useful to you, and stay tuned for more videos.